So yeah, drawing a control panel can be a bit tricky, for especially when it's your first one that you will be doing. So now you start with your mini MCBs, miniature breakers, MCBs. That's your breakers. You always start with a protection. In most cases, as you grow advanced, then you'll know where you can also juggle around with the protection devices or protection switches. So you start with your breaker, and then that is your line. Then you go to emergency contact. Next, you go to your overload, and there's a change that I've seen people doing, writing 95 and 94, 95 and 96. I'll advise people not to use that, because in some conductors they are old school, so they don't use those numbering system. That 95 and 96 is based on the manufacturer, so it's a new world. If you will be working in the old factory, then you won't be getting such numbers. So you must actually know on how to identify your overload switch. That is your normally closed of the overload. It also has the normally open, so that is the normally closed of the emergency switch, emergency stop, and then that's your overload switch. It's an overload. And then you can now go to your stop. Always want to start with what stops the system. That's a stop button. It's a stop button, and then you go to your start button. Then you can go to your start button. The start button will be your normally open, normally closed, normally closed, normally closed. And the start button, remember, your start button is a push button, so immediately when you press that, it will somewhat jump out by itself, because it's a spring-loaded switch. Then that is not a spring-loaded switch. You need to push it in or push it out and pull it out. So then we will go to the auxiliaries now. We are doing forward and reverse, or yeah, we can do forward and reverse. And then we go K1 for A1, A2. So with this, this is a direct online. When you press start, there's only one motor here. This press start, then this conductor will energize, and then it will actually get power, and then the motor will actually eventually run. That's line 1. Let's take this as a 220 supply. 220 supplied, meaning that side will be a neutral. So then if I press start, then that coil will energize. So that's why it's important to understand the operation of your contactor, because you clearly know when you press start, the auxiliaries of your contactor will change their state. If it was on the normally open, then it will change to closed. The normal closed will move to open, meaning that what can we do in order to keep that start button, to keep that motor running? Because when we start, you push that press start button, you press that start button, it automatically will shoot up when we release the or when we pull our hand out. So we use auxiliaries. We make use of auxiliaries. Then, because we do not want, remember, if that breaker is down, then the power can flow up until this point. This is a point whereby electricity can flow. So then we do not want that motor to start before us having to press the start button, meaning that we'll be making use of the normally open auxiliary. What will happen if you use the normally open normal closed auxiliary? Then immediately when we switch that thing off, the mini circuit breaker, then the motor automatically will start, and it will eventually never stop. So we need to name that K1, that it belongs normal open, it belongs to that one, K1. Now we want to do that one is going forward, or we can say start delta. You can do a start delta. Okay, saying forward to 1, to 1 forward, yes. So what also we don't want to do is that when that motor is running forward, the other one mustn't run. This one will be running forward, and the second one will be controlling the motor that will be running backward. Reach that, the neutral. That's our start. Same principle, but now we'll be using the auxiliary of the motor that will be running, meaning that now that's why it's important to label your auxiliaries so that you can clearly know where it belongs. When you're doing fault finding or you have a fault onto your system, you can go exactly to that point. So when you press start, that motor can run. But now let's say backwards or reverse. So now what else we also don't want this motor to do? If that motor 1 is running, we do not want motor 2 to be running. So motor 1, motor 2. How can we accomplish that? Because you only want to stop one mode. You don't want to stop both motors at the same time, or you don't want to each and every time you don't want to stand in front of the control panel stopping the motor 1 from running while motor 2 is running. We make use of auxiliaries by doing that, meaning that if auxiliary of K2 is open, then it will automatically cut off the power of K1. How can we do that? Okay, make use of that by doing introducing a normally closed circuit of K2. Immediately when this motor runs, that one will cut off power, and then that one will still be running. So that is how we make use of the auxiliaries, by knowing what do you want to do. You must always ask, what do you want the motor to do? Do you want it to give a pilot light? Do you want it to, when you switch on the circuit breaker, do you want the lights to go on? Do you want the light to go off? That is why it's important to know what is it that you want the system to show you or to do. Hopefully on that one you you'll understand and find some bit of help when you're preparing for your trade test for those doing electrical engineering.